Hello everyone, welcome to Drawing Hub. This is Sanjana, and in this video we'll be continuing with Distributed Computing Module 1 Part 3. In the previous session we have already discussed about the motivations of distributed system and many other things like middleware, the basics of distributed computing, the features of distributed computing and all. So if you want to know more about the topic, please visit and watch my previous videos. Let's get started. So in this video, we'll be covering the primitives for distributed communication. So when you just see these terms, don't get terrified at the sight of these terms. We'll learn through examples. Let us imagine a real life situation. You sent a WhatsApp message to your friend. There are three things that can happen. Situation 1 is where you send the message, you wait until your friend reads it, and only then you continue your work. Okay, you will wait for your friend to read the message and give you a reply. This is called synchronous communication. You're waiting for your friend. In another situation where you send the message and you immediately continue studying, or you are doing whatever work you were doing already. You're not waiting for the reply from your friend. That is called asynchronous communication. So here what you have to notice is not the difference whether you stop working or not. It's not about that. It is about, does the sender wait until the receiver receives the message? Is the sender waiting until the receiver receives the message? That is the definition of synchronous and asynchronous. Now let us move on to the send function and receive function, which is quite common. We know that every communication has two operations. If there is a computer A and there is a computer B, then computer A sends a message and computer B receives it. It is just as simple as that. One sends and one receives. These are called communication primitives. Next, we need to know and in this, as you can see, send function and receive function is there. In send function, there is a destination. Where is the message going to? Where is the destination? Where is its end point? And where it is being stored. Then in receive function also, there are two parameters here, where the source is from what is the origin of the message and where it should be received to. These are the two primitives you should know, send function and receive function. In the send function, what happens inside? Suppose we want to send a message, hello. Does it go directly to the network? Sometimes it will go directly, sometimes it will not. And that is where there are two methods, buffered and unbuffered. Buffered communication and unbuffered communication is there. Buffered communication, this is the most common. We'll see that through an example. Imagine you're sending a parcel. Okay, you're sending a parcel. Instead of giving it directly to the delivery truck, you need to give it to the delivery truck before supplying, of course. What you do is you will keep it first in the warehouse. Imagine that scenario and connect it with the technical things. The data is there in your buffer. You are moving it to the kernel buffer. The kernel buffer here is the warehouse, a buffer where you can temporarily store it. Then there is a network. The network is the delivery truck. And receiver is where the parcel is being distributed, right? Okay, so your buffer, the data is stored to kernel buffer from your buffer. And from the kernel buffer, it is moved to network and the network will give it to the receiver. Why we are doing this is because sometimes if the network is busy, at that time network cannot hold it, the data. So the kernel will temporarily store it. That is buffered option. Then unbuffered option is where there is no temporary storage in it. That is, you hand the parcel directly to the truck. You are not storing it anywhere. From user buffer, the message is going directly to the network. There is no temporary storage. Unbuffered communication is faster because it is not being stored anywhere, right? But it is less flexible. Okay. Now you have understood the basic thing of what synchronous and asynchronous is. Synchronous is after calling a send function. Is the sender waiting for the receiver? Yes or no? If the sender is waiting, that means it is synchronous. If it is not waiting, then it is asynchronous. Okay. This is the figure for synchronous primitive. In synchronous processing, there is, as you can see, there is a process A and process B. The process A will call for process B and it will wait that much time. Whatever work process A was doing, it will keep it. It won't do it. It will wait for the response from process B, only then it will continue working. That is synchronous primitive. In asynchronous primitive, what will it do? It will not wait for the response from B. It will continue working on process A itself. The process A will continue working whatever task it was doing, it will continue doing that. That is asynchronous primitive. Then comes blocking primitive. Okay. Yeah, this is something which you might get confused between blocking, non-blocking, synchronous and asynchronous. So just listen to this carefully. Blocking. Imagine you click in your system, you're clicking print document and your laptop freezes. In this situation, you cannot do anything. It is hung. It's completely unoperable. And you will have to wait. And once it fixes its internal issues, it starts working again, or maybe you'll have to restart it and all. So that wait, that is called blocking. A blocking primitive returns control only after the operation completes. Only after whatever internal operations is done. Only after whatever is done internally, the operations completed. Only after then the control returns. In real life, if we are saying you are going and downloading a file, and then you wait until the download is finished. And only after the download is finished, you will continue your work. That is blocking. Now, if you're coming to non-blocking is where, imagine Chrome. Okay, you start downloading your file and you're not waiting for that file to finish. You open another tab and you continue your browsing, or you're doing whatever work it is. That is non-blocking. Here the control returns immediately. That doesn't mean the communication is not happening there. The communication is still happening, but the control returns immediately. That is the basic thing of what blocking and non-blocking is. Now, you do not get confused between blocking, non-blocking, synchronous and asynchronous. Ask yourself, is the sender waiting for the receiver? If it is waiting for the receiver, if the sender is waiting for the receiver, then it is synchronous. If it is not waiting, then it is asynchronous. That is different. In blocking, non-blocking, is the function returned immediately? Is the control returned immediately? If the control is returned immediately, even if the communication is happening, that is non-blocking. If the function is not returned immediately, that is blocking. Don't get confused between these four. That is non-blocking primitive. Then check for completion. We can check if a work is completed. The process can check if a work is completed. First, either it can keep checking in a loop or periodically if a flag or if there is any post. Okay, if the handle has been flagged or posted. Second is where it can issue a wait function with a list of handles as parameters. Then comes 4 versions of send primitives. So we have already learned what synchronous is, asynchronous is, blocking is, non-blocking is. And the combination of all of these is the 4 versions of send primitive. Synchronous blocking, synchronous non-blocking, asynchronous blocking, asynchronous non-blocking. We will learn these all in detail in the next video. Till then, bye-bye.